Okay, in this video, we're going to start by just revising what we mean by independent events, and then we're going to go on to look at dependent events. So first of all, independent events are where the outcome of one event doesn't affect the other. So for example, when you flip a coin, whenever you get, say you got heads when you flipped a coin, if you flip the coin again, so that's your second event, the probability is still a half. It's not affected by whether or not you got a head or a tail the first time. So if the probabilities are not affected by one another, then those are independent events. So the way we calculate that is by saying, the probability of getting one event and another event, so the probability of A and B is whatever the probability of A is times the probability of B. So we're going to look at how that applies to independent events, and we're going to use tree diagrams to help us calculate the probabilities. So this example says when you roll a dice twice, what's the probability of getting 2 6s or at least 1 6? So in this case, we're only concerned with whether or not we roll a 6 or not. So when we draw our tree diagram, what we're drawing here is on our first roll, so this red bit represents the first time we roll a dice. We either get a 6 or we don't get a 6. So remember that dash tells us we don't get a 6. So along the branch, I'm going to place the probability of each event. So the probability I get a 6 is 1 6. So that means that the probability I don't get a 6 is 1 minus that, which is 5 6. Okay, so I either get a 6 or I don't get a 6. Now, the second time I roll the dice, I'm still looking for whether or not I get a 6 or not. So the second roll is represented here, so I can get a 6 or not get a 6. And then this branch represents like what happened if I didn't get a 6 first. The second time I could still get 6 or not get a 6. Okay, and the probabilities don't change. It's still a 1 in 6 chance of getting a 6, or a 5 in 6 chance of not getting one. And same for down here, 1 6, 5 6. Now what's helpful about a tree diagram is a tree diagram helps us to list all the possible things that could happen. So I'm going to list those at the end of each of the branches. So if I follow this first branch here, this is me getting a 6 the first time and a 6 the second time. So I'll just list that here. That's getting a 6 and then another 6. And so to calculate the probability of that, I multiply the probabilities along the branches together. So a 6 times a 6. And that gives me a probability of 1 in 36 of rolling a 6 the first time and a 6 the second time. Let's look at the other outcomes. That pretty much answers part A, but let's just do all of the outcomes anyway. So I'm just going to change the color here to help us see better. Now the second thing that could happen is I get a 6 the first time and I don't get a 6 the second time. So I get a 6 the first time and no 6 the second time. So for those probabilities, getting a 6 the first time is 1 6. Not getting a 6 the second time is a probability of 5 6. So when I multiply those together, I get probability of 5 over 36. Okay. The third case that can happen is I don't get a 6 and then I get a 6 on the second roll. So I don't get a 6 and I get a 6 on the second roll. Now those probabilities are 5 6 times 1 6. 5 6 times 1 6, which again gives me a probability of 5 out of 36. And the last thing that could happen is I don't roll a 6 on either dice. So I don't roll a 6 the first time and I don't roll a 6 the second time. So that probability is going to be 5 6 times 5 6, which equals 25 over 6. So, sorry, 25 over 36. Now these are all, so I've got 4 different things that can occur. Now all of these here 1/36 plus 5/36 plus 5/36 plus 25/36 should add up to 1 because that covered all of the possible outcomes. So the probability of all the outcomes together has to equal to 1, and it does, because if you add the numerators up, I get 1 plus 5 plus 5 plus 25, that gives me 36 out of 36, which is 1. Okay, so that's a good way to check that you've got all the probabilities. Now, part A said what was the probability of getting 2 6s, and I can see that that was just 1/36, because that's just that first outcome there. The second bit says, what's the probability I get at least 1 6? So that happens 3 times. At least 1 6 happens here, it happens here, and it happens here, because technically 2 6s is at least 1 6. So I can add now all of those probabilities together to get the total probability. So I can either get 2 6s, 1 6, or 1 6. So adding those together, 1/36 plus 5/36 plus 5/36 gives me a total of 11/36. So the probability I roll at least 1 6 is 11 out of 36. Let's look at one more example. You're free to try this one on your own if you like. So on his way to work, Paul passes 2 sets of traffic lights. The probability the first light will be green is 0.7, and the probability that the second light will be green is 0.5. So we want to know what's the probability he doesn't get stopped at either light, and what's the probability he gets stopped at both lights. Okay. Now, our first event is, I'm going to call them, should we say, what's the probability the light is green, and what's the probability the light is not green? So on the first light, it says the probability it will be green is 0.7. So I'm going to put 0.7 here. So that means the probability it's not green has to be 0.3, because those have to add up to 1. Now on the second traffic light, the probabilities are slightly different. And that can happen because of the flow of traffic. So on the second light, the probability that it will be green is 0.5, and the probability then that it won't be green is 0.5. Okay, and we need to draw our second set of branches here. So this is still the second light, but we're just looking at what happens if the first light had been red. So again, the probabilities are 0.5 and 0.5. Now in A, it says what's the probability he doesn't get stopped at either light. So what that's saying is, what's the probability both lights are green? I'll use a green pen for that. So that's this probability times this probability. So we're saying, okay, what's the probability I have a green light and I have another green light? So that's 0.7 times 0.5, which is 0.35. So there's a 35% chance that both lights are green. And now let's look at what happens he gets stopped at both lights. So that's not a very fun situation. So getting stopped at both lights means they're both not green. So the probability of it not being green and it's also not green is going to be 0.3 times 0.5, which is 0.15, okay, or 15%. So those are my examples of independent events. We're going to go on to dependent events now. Okay, now we're going to look at some examples of probability of dependent events. And dependent just means that the second outcome depends on the first. So in this example, I've got 7 socks here. So 7 different color socks, 4 purple and 4 green. So imagine those socks were in your drawer and it was the middle of the night or early in the morning, it was still dark out, and you just reached in and grabbed 2 socks. What's the probability that you're going to pull out a matching pair of socks? So what we're asking here is, what is the probability of getting 2 green socks? So I'll put green, green, or, and remember that's our symbol for or, the probability of getting 2 purple socks. And we know that when we say or, to work out that probability, we just work out the probability of the first one, 2 greens, plus the probability of the second one, 2 purples. So it's helpful to draw a tree diagram in this case. So the first sock we choose either is going to be purple or green. Now the probability that I pick a purple one is 4 out of 7, because I've got 4 purples out of 7 socks. And the probability I choose a green is 3 out of 7. So let's look at each of these cases. So the first sock I choose is purple. Now when I go to choose the second sock, the probabilities have changed because I've only got 6 socks left. So I can still, for my second one, either choose purple or green, but this time the probability of choosing a purple is 3 out of 6, or I can just simplify that to 1/2. I'd suggest simplifying because it's going to make the maths a bit easier. And then the probability of getting a green is also 1/2. Now let's look at the second situation that could have happened. So that was if I chose a purple sock first. If I chose a green sock first, this is what happens. So now I'm still left with 6 socks, but this time the probability of getting a purple is 4 out of 6, or 2/3. And the probability of getting a green then is 1/3, or 2/6. So do you see how for my second event, the probabilities have changed for the first event, and that is dependent on whether we choose a purple or a green sock first. Okay, so now what I'm interested in is, first of all, what's the probability of getting 2 greens? So I'll just write that down here. The probability of getting 2 greens is going to be the probability of 1 green times the probability of another green. So 3/7 times 1/3, which is a probability of 3 over 21, or 1/7. Okay, so that's the probability of getting 2 greens. Now we need to work out, I'll just put a square around it so we can see it, the probability of getting 2 purple socks. So the probability of 2 purples is going to be 4/7 times 1/2. 4/7 times 1/2, which gives me 4 over 14, which is the same as 2/7. So I've got the probability, oh, sorry, you can't see that there, I'll move that up. So I've got the probability of getting 2 greens is 1/7. The probability of getting 2 purples is 2/7. So the probability of either getting 2 greens or 2 purples, we add those together. So that gives us, and I'll just move this up a bit more so we can see. So the probability of 2 greens plus the probability of 2 purples is 1/7 plus 2/7, which gives me an overall probability of 3/7. So the probability of choosing a pair of socks, so a matching pair, is 3/7.